All right, when we talk about AWS Lambda, everyone gets excited about its power to scale, right? But what happens when that scaling just stops? Today, we're going to demystify AWS Lambda quotas. And here's the key. I want you to stop thinking of them as limits and start seeing them for what they really are, essential safety features.
You've been there, right? Picture this. Your app is humming along, scaling perfectly, handling all the traffic you can throw at it. And then, boom, it just stops. Requests start failing out of nowhere. So, what happened? Well, you probably just hit an invisible ceiling you didn't even know existed.
So, what is this invisible ceiling? In the AWS world, we call them service quotas. And honestly, the best way to think about them is like guardrails on a highway. They aren't there to ruin your fun or slow you down. No, they're there for two really important reasons: to protect your account from a surprise, runaway bill, and to make sure the entire AWS platform stays stable for you and, well, for everybody else.
Okay, so if we're going to navigate this serverless highway, you've got to know that not all guardrails are created equal. They actually come in two very different types. And trust me, understanding this difference is the key to building apps that can really truly scale without hitting those walls. First up, you've got your soft limits. Think of these as adjustable. They're like a safe starting point that AWS gives you, but as your app gets bigger and needs more power, you can just ask AWS to raise them. The classic example here is concurrent executions. Then on the other side, you have hard limits. These are totally different. They're like the concrete foundation of the service. They are fixed, you can't change them, and they define what Lambda fundamentally is and isn't.
All right, let's dive into the first category, the core performance limits. These are the in-flight rules, the ones that are in effect while your function is actually running and doing its job. They basically define how much horsepower your function has.
So the first big number that everybody talks about with Lambda is this one, 1,000. This is the default number of concurrent executions you get in a single AWS region. It's kind of the standard starting point. Now, it's worth noting, super new accounts might start a bit lower and grow into this, but 1,000 is that key number to have in your head.
And the most important thing about that 1,000 number, it's a classic soft limit. This means if your app starts getting really popular and you need to handle more than 1,000 requests at once, you're not stuck. You can just ask for an increase, and you can go up into the tens of thousands. Honestly, this is probably the single most common limit people adjust as they grow.
Okay, now this next one is super important and something that trips people up. In Lambda, memory and CPU power are tied together. When you pick how much memory your function gets, you are also picking how much CPU it gets. They aren't two separate sliders you can adjust, they're linked.
And you can see that relationship right here. The range is pretty huge. You can go from a tiny 128 megs all the way up to over 10 gigs of memory. But check out that sweet spot in the middle. Once you give your function 1,769 megabytes of memory, you get the power of one full vCPU. Anything less than that, you get a fraction of a vCPU. Go above that, and you start getting even more processing power. It's all about finding the right balance for your workload.
And here's a big one, a hard limit. No exceptions. Your Lambda function has a maximum of 15 minutes, that's 900 seconds, to do its thing. If it's not done by then, Lambda just cuts it off. It's terminated. This isn't something you can ask to increase. It's a fundamental rule of the road you have to design your entire application around.
Okay, so that covers the rules for when your function is actually running. But what about before that? There are also guardrails for how you package and deploy your code. Let's get into those.
This really lays out the size limits pretty clearly. If you're going the traditional route with a zip file, the file you upload can't be bigger than 50 megs. But what really matters is the size after it's unzipped. All your code and all its layers combined have to fit under 250 megs. Now, what if you have a huge machine learning model or something? That's when you look at using container images. That blows the doors open, giving you a whopping 10 gigs to work with.
And here are a few other really important deployment guardrails, and these are all hard limits. You can only have up to 5 layers for your function. Your environment variables, they can't be more than 4 kilobytes in total. And the temporary storage space, the /temp directory, gets up to about 10 gigs. Now, this last one is super important. The invocation payload. For a direct synchronous call, you can send and receive up to 6 megs. But for an asynchronous call, it's way smaller, only 256 kilobytes. That's a huge difference you have to plan for.
All right, so knowing the rules of the road is step one, but the real goal is to master them, right? So let's talk about how you can get ahead of these quotas and make sure you're always in the driver's seat when it comes to scaling your app. First things first,
Your number one tool is the AWS Service Quotas dashboard. Seriously, don't just guess or rely on what you read in a blog post somewhere. Go to this dashboard. It will show you the exact limits for your account right now for Lambda and every other service. This is your ground truth.
And the best part? If you see a soft limit you need to change, it's super easy to do it right there. You just go to the Service Quotas dashboard, pick AWS Lambda, find the one you want to raise, like concurrency, and click the button to request an increase. It's that simple.
So why is being proactive about this so critical? Well, here's a perfect real-world example. By default, API Gateway can handle a massive 10,000 requests per second. But, as we just learned, your Lambda functions behind it can only handle 1,000 at a time by default. See the problem? If you don't manage this, your front door is letting in way more people than your backroom can handle. You're creating your own bottleneck.
And that leads us to the single best way to stay ahead of all this: load testing. You have to do it. It's the only way to really know where your application's breaking points are. A proper load test will shine a giant spotlight on these quota bottlenecks long before your actual customers run into them in production.
So let's bring it all home. These quotas, these service limits, they're not there to stop you. They're the guardrails. They're there to keep things safe and stable. Once you understand them, keep an eye on them, and adjust them when you need to, they stop being walls and start being a roadmap for scale. So your app is protected. The real question is, are you ready to hit the gas?